Welcome to solverfy.
This is the answer to Chapter 19, problem number 35 from the Smith Organic Chemistry textbook. And in this problem, this problem says using the pKa table in Appendix A, determine whether each of the following bases is strong enough to deprotonate the three compounds listed below. And so our bases are the five bases listed at the end of the question here. And then we have these three molecules for which the pKa is given. And so remember, the way that this is going to work is if the pKa of the conjugate acid of each of these bases is higher than the pKa of the molecule that it's trying to deprotonate, then it is going to be able to deprotonate that molecule. And if the pKa of the conjugate acid of a base is not higher than the pKa of the molecule it's deprotonating, then it will not be able to deprotonate it. So for the first molecule here, the methyl benzoic acid, each of these bases is going to be able to deprotonate that molecule. So I felt that a table was the best way to answer this. So what I've done is I've listed the bases, and then I've drawn their conjugate acids, and then I've written the pKa of the conjugate acids. And so I think that makes for an easy comparison to the pKas of these molecules. So for the first one, each of the pKas of the conjugate acids is higher than 4.3. So the answer is going to be yes down that whole column. So for the second molecule, it's going to be 4 yeses and a no. So 15.7 is higher than 9.4, 50 is higher than 9.4, so is 38. However, 9.4 is equal to 9.4, and so no deprotonation is going to occur there. So that's the no. Ammonia, the conjugate acid being the ammonium ion, that's not going to be strong enough of a base to deprotonate this parachlorophenol here. And then the third molecule, this tert-butanol, so 15.7 is not higher than 18, so that's going to be a no. 50 obviously is. 38 is higher than 18. 9.4 is not higher than 18, but 25 is. Okay, and so that's the way to do this. We need to look at the bases. We need to consider their conjugate acids, and then find the pKa of each of the conjugate acids in the table in Appendix A, and then compare the conjugate acids pKas to the pKas of the molecules that they are trying to deprotonate. And if the conjugate acid has a higher pKa than the molecule to be deprotonated, then that deprotonation will occur. And that's the answer to Chapter 19, problem number 34.